Namaskar. Today we talk about our new topic, Schrodinger wave equation. Before starting that, we discuss some points. The one of the most interesting point is the superposition. What is the superposition? Let me understand with the help of Schrodinger cat experiment. For example, we have a cat. We have also a box. In that box, a radioactive element is present there. When we close this cat in this box, the probability or the chances that this radioactive element kill this cat is 50%. Kill this cat is 50%. When this box is closed, and the chances, some people say the cat is dead and some people say the cat is alive. So there are the two possibilities. One is that dead and one is the alive. No one can 100% predict that the cat in that box is dead or alive. So there are different views on different times. But whenever we open this box, we can definitely see that cat is dead or alive. So there are the two superpositions. One superposition is that the cat is alive, there is the 50% chance, and another one superposition is cat is dead, there is a 50% chance the cat is dead. So there are the 50% chances that cat is alive or cat is dead. Schrodinger wave equation. Quantum mechanics, that the newest branch of the mechanics, is developed by Heisenberg and Schrodinger. The fundamental equation of quantum mechanics is given by Schrodinger. Due to this equation, Schrodinger won Nobel Prize in Physics in 1933. This equation incorporates wave-particle nature of matter. It means the wave nature and particle nature of the matter, the dual nature that is proposed by the de Broglie. So this one is the incorporation of wave nature plus particle nature of matter. For the wave motion of the electron in the three-dimensional space around the nucleus, the equation is as follows: d square psi divided by dx square plus d square psi divided by dy square plus d square psi divided by dz square plus 8 pi square m divided by h square into E minus V into psi is equals to 0. This equation is known as the long form of Schrodinger wave equation. In this one, x, y and z represents coordinates of electron waves. Psi, that is known as the amplitude of the wave. Amplitude of the wave means the maximum displacement from the mean position of a wave is known as the amplitude. E stands here for total energy of electron, V stands here for potential energy of the electron, and the last one, H, stands here for the Planck's constant. So this is known as the long form of Schrodinger wave equation. This one is the short form of Schrodinger wave equation. In this short form, the h cap into psi is equals to E psi. H cap into psi is equals to E psi. This h cap is known as the Hamiltonian operator. H cap is known as the Hamiltonian operator. What do you mean by the operator? We can easily explain what is the operator. An operator is a mathematical command given to a function to get another function. That is a mathematical command given to a function to get another function. That is the under root 4x square value is the 2x. Here the square root is the mathematical operation. Square root is the mathematical operation on the function of 4x square. By that we got the value 2x. The symbol of cap is used for operators. We could write this equation like r cap. R mean square root. R cap of 4x square is equals to 2x. So r cap represent taking square root. Similarly, we have that h cap Hamiltonian operator. H cap is equals to h square upon 8 pi square into m into del square plus v. Here a new operator comes del square. That new operator del square is known as the Laplacian operator. The value of the del square is del square by del x square plus del square upon del y square plus del square upon del z square. So this one is the short form of Schrodinger wave equation. We have the two forms of the Schrodinger wave equation, long form as well as the short form. The solutions of Schrodinger wave equation for an electron in an atom give the value of E and psi. E mean total energy and psi mean wave function. The value of the E represent the quantized value of energy which the electron in the atom can have. The corresponding value of the psi are called the wave functions. There is so many energy levels are present in atom. All the energy levels are quantized. Energy of those levels is quantized. Significance of psi and psi square. Psi mean wave function and psi square mean probability of finding an electron. As we know, the psi have no physical significance, but psi square tell us about the points of the probability of finding the electron at any particular point, or a psi square value is indicating electron density at a particular point. Since the region around the nucleus which represents the electron density is called an orbital, that is why the wave function for an electron in an atom is called orbital wave function, or simply known as the atomic orbital. Since an electron can have many wave functions, so therefore there are many atomic orbitals in an atom. Those are related to different quantized energy levels. Quantum mechanical model of atom. Now we look about the concept of the orbital. Before that, we know only about the orbit. After the quantum mechanics, a new concept is came there, that is known as the orbital. In this one, in the light of the uncertainty principle that is given by the Heisenberg. According to that, simultaneously we cannot find out exact position and momentum of any electron or electron-like particles. Bohr model of atom postulating that the electron move along definite circular paths and hence their position and momentum could be determined with absolute accuracy become unacceptable due to the uncertainty principle. Now we can speak on only in term of probability. Probability means superpositions, or simply say probability. Probability of the finding the electron at any particular position about the nucleus at any instant of time. Keeping in view the wave nature of electron and the uncertainty principle, the movement of the electron around the nucleus is like that of a bee around the hive. Sometimes it may come close to the hive or sometimes that move away from the hive. In the same way, sometimes electron come near nucleus and sometimes that electron go far away from the nucleus. It does not move in one plane. Electron does not move in a one plane, that is moving in all the possible planes in a three-dimensional. The concept of the probability may be understood with the help of the following simple examples. Let's look with some examples. The first condition, there are the clouds in the sky. So probability is that maybe there is a rainfall. Certainty, 100% surety is there? No, there is no surety that if cloud in the sky, there is rainfall. In a game, A is better player than compared to B. So the probability is that A maybe win the game. But is the 100% sure? No, there is no surety, there is no certainty that player A win game. A car is moving with very high speed. So the probability may be that car collide with another or collapse with another. So probability is the accident. But there is a certainty of accident is no. There is no 100% surety that car accident. No chances. So this is the probability. Probability will tell us for a condition that may be happened or not. So there is a chances, different chances are there happening, chances are there. So probability provide the best possible description of a situation which cannot be described with certainty. So probability provide the best possible description of a situation which cannot be described with certainty. Certainty means 100% surety. Look, for example, we have this nucleus. Around this nucleus, the position of electron may be this one. Now we take a picture of this position of electron along with the nucleus. After some time, the electron is present on any other part of this space. Now we again take a picture. So every time simultaneously we are taking some pictures whenever electron is present at another positions. So every time we are taking some pictures of this movement of electron around the nucleus in this 3D space. After taking a lot of pictures, we arrange all those pictures in a manner like that in this one. So these are the pictures. Here are the lot of the pictures that we capture during the movement of the electron. Now what we do, we superimpose these images on each other. We superimpose these images on each other. It means we put our second image on the first, again third image on second, and the fourth image on third. Like this way, superimpose all these images. After the superimposition of all these images, we got such kind of the image, in that these dotted points are indicating the position of the electron. Maybe electron is found here, or maybe electron find is here or there. So these are the different positions. So these dots are indicating the position of the electron on different time interval in atom. On the different time intervals in atom. So density of the dots represent the probability density of finding the electron in that region. So this one is the dot diagram for orbital, and this one is the boundary surface diagram for an atom. The region of space around the nucleus which describe the probability of finding an electron of given energy in term of the dots is called an electron cloud. So this orbital is also known as the electron cloud. When we connect these dots of equal probability, we got a shape. That shape is known as the boundary surface diagram. It is known as the boundary surface diagram. Nowhere is the probability of finding an electron equal to 0. Even at a very large distance from the nucleus, there is a finite though small probability of finding an electron of a given energy, but nowhere is 0 probability. Anywhere there is some probability of finding electron. This means that electron clouds do not have sharp boundaries. However, for sake of pictorial clarity and the convenience of representation, a boundary surface may be drawn which connects points of equal probability and encloses a certain volume of the space around a nucleus within which the probability of finding an electron of given energy is maximum, say more than the 95%. Like this can be an atomic orbital. That area there the probability of finding an electron is maximum, that area is known as the atomic orbital. An atomic orbital may be defined as the 3D space around the nucleus within which the probability of finding an electron of given energy is maximum. Where the given energy is maximum, that is 3D area around the nucleus in an atom. It is known as the orbital. Difference between orbit and orbitals. These are the few differences between orbit and orbitals. Orbit is a well-defined circular path around the nucleus in which the electrons revolve. So this is the 2D path. But an orbital is a 3D path around the nucleus within which the probability of finding an electron is a maximum. Orbit represents the planar motion of an electron around the nucleus, but orbital represent the 3D motion of an electron around the nucleus. The concept of an orbit is not in accordance with the wave character of electrons and uncertainty principle. But on the other hand, orbital is the concept is with the accordance with the wave character of electron and uncertainty principle. So this one orbitals agree with the Heisenberg uncertainty principle. All orbitals are circular and disc-like shape, but in the case all the orbits are circular and disc-like shape. But in the case of orbitals they have different shape, like s orbital spherical, p orbitals are dumbbell shaped, d orbitals are double shaped, like this. Orbits do not have any directional property, but in the case of the orbitals, except the s orbital, all the orbitals like p, d, f, those are directional characteristics. There are the direction. P orbital, there are the three type of the p orbitals like px, py and pz. So px mean the direction is the x, py mean direction in y axis, and pz mean direction in z axis. The maximum number of the electron in any orbit is given by 2n square, where n is the number of the orbit. The maximum number of the electrons present in any orbital is 2. Orbital can accommodate only 2 electrons, but an orbit can accommodate 2n square electrons. For example, first orbit accommodate 2 electrons, but the second orbit accommodate 8 electrons, and so on. but in the case of the orbital, that can accommodate only 2 electrons. So these are the few differences between orbit and orbital. Important feature of the quantum mechanical model of atom. The first one is that the electron in an atom have only quantized value of energy. So the value of the energy for each energy level is fixed. These quantized value of energy are obtained from the solution of Schrodinger wave equation. The corresponding value of the wave function psi are also obtained from the solution of Schrodinger wave equation. The wave function psi has no physical significance as we know, but the psi square gives us the probability. The concept of the probability is justified in the view of Heisenberg uncertainty principle. Wave function psi is called orbital wave function or simply atomic orbital. Since an electron can have many wave functions, therefore there are the many atomic orbitals in an atom. The orbital wave function psi contains all the information about an electron in an atom, and quantum mechanics help to extract this information for electron in a particular atom. Applications of Schrodinger wave equation to hydrogen atom. When Schrodinger wave equation is solved for the hydrogen atom, the solution gives possible value of the energy. These value of the energy correspond to the energy levels which the electron in an atom can occupy. These value of energy are called eigenvalues or eigenfunctions. The positive values, the positive solutions of Schrodinger wave equation is known as acceptable solutions is known as the eigenvalues. The corresponding value of the wave function psi is called eigenfunctions. The quantized value of energy and the corresponding wave function of the electron are characterized by a set of quantum numbers. It may be noted that the Schrodinger wave equation cannot be solved exactly for a multi-electron atoms. It is solved for hydrogen and hydrogen-like species. Those are containing only one electron. For the multi-electron system, it cannot be solved completely or exactly. Thank you for listening us.